This device is a training equipment for motor disassembly and maintenance skills. The primary function of this training bench is to provide power to the motor. Check whether the motor is functioning properly. Next, I will introduce its components. This is a module for overall power supply. This is a three-phase power regulator. Turning to the left will output the three-phase power supply on the left. Turning to the right will output the three-phase power supply on the right. DC voltmeter, DC ammeter. A power supply on the AC side. These are some of its voltmeters. This is an AC voltmeter. DC ammeter, DC voltmeter, AC ammeter. This is a multifunction watch. It can directly replace the voltage and current here for testing. This side is full of AC ammeters. Here, it's also about power supply. Here are some components. This is the resistor component. This is the switch. It can be turned to the left or right to represent different values. This is an inductor, which can also be rotated to the left or right. This is a capacitor, which can also be rotated to the left or right. This is a star-shaped motor. This is a triangular motor. The motor here is adjustable and can be tested. The resistance is 1000 ohms. So, the resistance here is 100 ohms. It is adjustable. This is a voltage regulator. This is an emergency stop switch. This is a controller. This is a voltmeter and an ammeter, both of which are adjustable. Three-phase AC motor. DC AC motor. Three-phase AC motor with excitation. This is a hand-cranked electronic counting winding machine. Its plug is connected to the socket over here. By shaking it with our hands, we can calculate a number on its side. A regulator for the total voltage. These are the components that the device probably includes. This is an introduction to the components of various functions. Next, we will conduct a practical operation on it. Before practical operation, it is essential to be familiar with all components and parts. Otherwise, there's a possibility of making a mistake. For example, if you want to measure direct current DC, you use an alternating current AC meter to do so. Then it might damage a table here. So we must pay attention to safety in use. When we test a three-phase motor, we must use three-phase current. This is the main power switch, which serves as a power input. Before we conduct the test, it is necessary to wear insulating gloves for operation. First, disconnect the main power switch. Then connect it and perform a check after the connection. If there are no issues after inspection, we can proceed with powering it on. Before connecting, we need to prepare wire harnesses of different colors and check if they are intact. Check each motor for loose connections, abnormal rotation, improper installation, etc. Similarly, it is necessary to check whether the table and terminals above are loose. Check if the functions of these components are normal. The emergency stop switch also needs to be checked. We can proceed with the power-on operation when we have checked and confirmed that there are no issues. Take out the three-phase wire bundles of different colors from the drawer. First, we will focus on wiring the three-phase motor. Three-phase motor represents U, V, and W. Connect the wire to the U terminal and then connect it to the L1 terminal. Connect the V terminal to the L2 terminal. Connect the W terminal to the L3 terminal. Then, let's take another wire harness and short-circuit the terminals below individually. Then, we can check it again, and if there's no problem, it's fine. The device is not currently powered on. We need to connect the power supply here. Connect the power supply to the training platform. Then turn on the switch over here, and you can see the motor rotating. It rotates counterclockwise. If you want it to rotate clockwise, just swap the positions of the UNW terminals here. It will rotate clockwise. Here, we just provide direct power supply to it. We want to know what its voltage and current are. For example, we measure the voltage of terminal U. First, let's connect the wires properly. Let's take another black wire harness and connect it properly. We also need to supply power to it. Connect this end to L1 and the other end to L. The power supply wire here should be connected to the N terminal over here. After connecting and checking, we turned on the power. The motor rotates. We can observe that the voltage fluctuates around 229 volts. Of course, we can also measure the voltage of the other phases in three-phase electricity. Next, let's measure its current. The current must be in series connection, not in parallel connection. First, we will start connecting from here. Unplug the W terminal connection. First, pass it through the ammeter. Output here. Connect it in series. Then turn on the power. We can see that the current of phase W is displayed as around 1.5 amps. By the same token, other phases can also be tested in this way. Next, we will test this multifunction watch. First, disconnect the power supply. Then connect the wire of the V terminal to the UV terminal. The N terminal is connected to the N terminal. Then we can proceed with the current test on it. This side is for voltage. We can see that the voltage is around 230 volts. We can also conduct connection tests on other phases. We can connect the Connect the U phase, which is also connected in series, to the LA terminal. Turn on the power. What we see is its voltage, and we can press the button to select current display. We can see that the current displayed on the multimeter is basically consistent with the current displayed on the ammeter above. So this is one of its experimental operations. After the operation is completed, turn off the power, remove the wiring harness, organize it, and put it away properly. This motor is a DC motor. It uses direct current voltage for testing, because the motor uses direct current. The output here is alternating current. So we need to convert DC current into amperage. Direct current is output to terminal A1 of the motor. The other wire is connected to the A2 terminal. Connect the F1 terminal in parallel with the A1 terminal. Connect the F2 terminal in parallel with the A2 terminal. After checking and confirming everything is correct, we can turn on the power switch. We observed whether the motor was rotating. It might not be rotating because its voltage is too low. So we need to adjust the voltage here. The motor will gradually rotate. Increase the voltage, and the motor's rotational speed will increase. Then the motor is working normally. After the operation is completed, turn off the main power switch. Reset to 0 here. Disassemble the wiring harness and tidy it up. Now, let's proceed to the next operation, demonstration of the AC excitation motor. The excitation motor is supplied with 24 volts DC power. Let's first connect the 24 volts voltage source. We connect the L1 terminal to the L terminal. Connect N terminal to N terminal. Then connect the positive pole here to the DC voltmeter. Connect the negative electrode to the negative electrode. We connect the power supply here. The N terminal on this side connects to the N terminal on the bottom. Then turn on the main power switch. We can see that both the voltmeter and ammeter above are powered on. But there is no voltage display on this side. We adjusted it to 24 volts. In this way, we can obtain its voltage. Because the voltage here is too low, it's difficult to read the readings. So this is the fastest way to read voltage. Let's turn off the power first. Connect this positive electrode next. Connect the wiring harness to the voltmeter. The W terminal is connected to the power supply of the W phase. Connect the V terminal to the L2 terminal. Connect the U terminal to the L1 terminal. Then proceed with the short circuit here. We need to check again after the wiring is completed. After confirming that everything is correct, we will turn on the main power switch. The motor starts to work. After the experiment is over, we will disassemble and tidy up the wiring harness. We directly measure the terminals here using a multimeter. This is the resistor. When we measure resistance, we must disconnect the power supply. Adjust the multimeter to the resistance setting. First, let's measure 100 ohms. Adjust the multimeter to the 600 ohm range. Adjust it to the left. Insert the pen into the terminals at both the top and bottom ends. We can deduce that its resistance is 100 ohms. Then adjust it to the 1000 ohm position. Then adjust the multimeter to the 6000 ohm range. Insert the probe into the terminal. It can be seen that the resistance is 1000 ohms. So, this is the detection of resistance. The inductance and capacitance here need to be tested using corresponding testers. Thus, the quality of capacitance or inductance can be tested. The terminals here also need to be tested using a multimeter. Use the buzzer function of the multimeter and the resistance setting here to test the resistance on his side. Similarly, this side can be adjusted. We connected its plug to the socket on the training platform. Then turn on the main power switch. Then press the switch to turn it on. It displays 0. If it's not already set to 0, we can press the 0 button to reset it. We can rotate it to drive the gear on this side to turn. The table will also display the changes in values. After our experiment is over, reset it to 0, turn off the switch, and unplug it. Then turn off the main power switch. Next, take out the power plug on this side. Put it away and set it aside. Then, put each motor back in place. That concludes the operation demonstration.